simplify now. So we're going to say simplifying. All right. Since we know 128 multiplied by 0 gives us nothing, we're going to say 0 plus 64 times 0 gives us nothing, plus another 0, plus 32 times 0 also gives us nothing, 0 plus, what is 16 times 1?
16.
16 plus, what is 8 times 0?
0.
0 plus, what is 4 times 1?
4.
4 plus, what is 2 times 1? 2. And then the 1 times 0 gives us 0. So we're going to add now. We only have 16 plus 4 plus 2. And what does that equal to?
22.
22. But when you write this, you should always have...
add the 10 with the 10.
Right. But because I don't have the fancy handwriting like you guys, I'm going to draw it. So you're going to have 22. Let's quickly draw it here. You're going to have 22. And you're going to put a fancy little 10 right below it like this. 22 to the base 10 is equivalent with 3 equal signs, or you could just say equal to 1, sorry, not 1, to 0, 0, 0, 0, 0, 0, 1. So I hope everybody got this. This is just brief revision. 1, 0, 1, 1, 0. So this is the homework. Everybody understand? But when you write this number that is base 2, guess what you should do? You should also put a 2 right below it there. Everybody with me? Let me just quickly...
Yes, sir.
Alright. But let me show you a little life hack. Let me show you a little life hack. Couldn't I have just said that this number is really 1, 0, 1, 1, 0? Isn't that the same value? Because since these 3 zeros didn't give me anything, I could really just say the number. Let me just erase this. Isn't this the same value? Agreed? Since these 3 zeros basically, think about significant figures now. If I tell you I have $0 million and 1 cent, how much money do I actually have in my bank account? 1 cent. Because I still don't have any value that is a million. I have 0 million. Right? You can say it as much as you want, but you're still not a millionaire. So you can say you have zeros to the 2 to the 7th power, but because it's not a value of 1, it won't actually be signified as a value that changes it. Because we just removed those zeros when we were answering the question. Alright, that was revision of the base 2 table. Now we're going to move on to, so thank you, Jazeel. I'm going to give you a point on the leaderboard. Good job. Now we're going to go back and take some notes on base 10 to base 2. What if I told you I had a number? So ready for me? What if we had a number such as 59 that we wanted to convert to base 2, which is 1s and 0s. Put that in bracket for me, which is 1s and 0s. Alright? Okay. I'm going to give you a pretty great diagram to look at in a few seconds. But the first thing, what does it mean to convert 59 to base 2? It really means how much time can I get to in 59. So write that for me. When we convert any number from base 10 to base 2, we really want to know how many times or how many twos rather, how many twos can we obtain in that number. Alright, now we're getting somewhere. So we just want to know how many times can I get 2 in that number. Alright, So let's start from the highest power of 2. What is the highest power of 2 that is close to 59? That's the first question. You're going to ask, what is the highest power of 2 that is closest to 59? Well, not closest to 59, but is
Sir, 2 is 6, sir. Sir, 2 to the power of 6.
Let's test it. Let's test it first. So
Wouldn't that be like over 59, sir?
right, so we can't take any value.
2 to the 5th.
So here's the deal. We can't take any power of 2 that is above 59. Alright? It must be...
Sir, 2 to the power of 5.
Let's test it though. So let's see if Khalil is right. So he says 2 to the power of 5. Let me put that in math statements. So that would be...
32.
32. Everybody agreed? Everybody see why? Because I can get a power of 2, which is 32, from 59. So here's what I'm going to do. I'm going to say 59 minus 32. And what does that give me?
27.
27. So we're getting somewhere. So 2 to the power of 5 is the highest power that I can get from 59. When I subtract it, that means what I have left when I do that is 27. The next step is, what is the next highest power that I can get from 27?
Sir, that would be...
Think about it.
2 to the 4th power.
2 to the 4th power. Okay, I like that. Let's try that. 2 to the 4th power. What is 2 to the 4th equal to?
16, sir.
Excellent. So now let's do that. We're going to say 27 minus the 16 as Kai said. See, I'm getting good at the voices. That's Kai, right?
Yes, sir.
Excellent. There we go. I'm getting good at the names. So 27 minus 16 gives me?
That would be 11, sir.
11. All right. So you see how we're breaking apart the number 59 by just looking at how many times I can get 2 from that number. Let's go to the next one. What is the highest power that I can get of 2 from 11?
2 to the 3rd power, sir.
2 to the
which
3rd.
is 8.
8. Right. So we're going to say 2 to the 3rd power. So this is the long method, but it's a shorter method that we're going to use. 2 to the 3rd power, which is 8. And then we're going to say 11 minus 8. That gives me?
3, sir.
3. Alright. And the last one, because obviously there's only one more time we can do this. What is the highest power of 2 that I can get into 3?
2 to the 1st power, sir.
Right. So we're going to say 2 to the 1st power. Right. Is equal to 2. And therefore, I'm going to say 3 minus 2 is equal to 1. So let's look at that. We only have one value remaining. So therefore, we have only one unit remaining. Let's see what this signifies. We have one unit remaining. So quickly take that off for me before I move on. And then we're going to explain this in shorter steps. And I'm going to see how well you guys are thinking. So I'm going to draw a little table. And you're going to tell me to fill in the blanks. So here we go. 59 to base 10. So you're going to put a little 10 below it. Because I can't do it, I want you to do it. Right? Just put that 10 right below right here. 59 to base 10 is equal to dash 32s plus dash 16 plus dash. So let me put a dash instead. Underline is good. Plus dash 8 plus a dash 4 4s plus a dash for 2 plus a final dash for 1. Alright. Now based on what we did earlier, how many 32s could I got out of 59? How many 30?
1, sir.
Right. So I'm going to put a 1 here. Let me bold it. Matter of fact, let me highlight it. I'm going to put a 1 here. So I've gotten 132. How many 16s could I get out of 59? Look at the second step.
3, sir. 3, sir.
No. How many times could I get 16 out of 30? Out of
27.
27. Yeah, sorry, my bad.
1, sir. 1, sir.
You're
1,
thinking.
Sir.
I like that. You're thinking. So you answered it correctly, even though I asked it wrong. But yeah, so we get 116 out of the remainder, which is 27. So we're gonna put that 1 here. All right. My next question is, because remember, we're pulling out the 32. So what is left? We pull 16 out of it. What is left? We pull 8. So how many times or how many 8s could I get out of the remainder, which is 11? So from
how many? 1, sir. 1, sir.
1. Okay, good. Let's put that. Put that right there. And then finally, well, not finally, but we have 2 more to go. How many 4s could I get from the remainder of 11 minus 8? So the 3 is remainder.
3.
Yeah. How many 4s could I pull from 3?
How many 4s?
Yeah.
Sir?
Could I pull any 4s?
No, sir.
So what do you think we're gonna do to put that we can't put any 4s?
A 0, sir.
Excellent. So now do you see the binary number falling out? Because we're gonna put a 0 here to say that, oh, I actually can't get any 4s. So we're gonna put a 0 there, and let's move along. So we have so far 1, 1, 1, 0. Let's try the 2 now. How many 2s can I get from the remainder of 3? 1, right?
Yes, sir.
Right. Let's put that. So put 1. And then finally, I told you that there was a remainder of 1. So I'm going to put that fact right here. I'm going to say remainder of 1 by just putting plus 1. Alright, let's write out this number now. So this number is equal to 1, 1, 1, 1, 1, 0, 0, 1, 1. 2 base 2. Alright, remember I can't write the 2 underneath, but you should put the 2 underneath. Everybody clear as mud? Clear as
Sir,
mud?
I can't hear anything because someone is humming.
Wait, one sec, let me see. Someone is in trouble. Oh, Kelly, you had a question? Kelly, you had a question? Oh, okay. Right. So yeah, any questions so far about what we just did of converting 59 to a base 2, which we found to be 111011? Everybody understand?
So the last remaining number, we should put it
Right.
after.
So if, for example, you have the last power of 2, which would be, let me click out for you. So look at this for me now. If the last remaining power of 2, why is this an error? Oh, there we go. If the last remaining power of 2 gave you a remainder of 1, you can't have a power of 2 that goes into 1. Because remember, 2 to the power of 0 would be just 1. So therefore, you just add that 1 as the remainder. Understood? Because we only have 1 unit remaining. So the answer would be 132, 116, 18, 0 4s, because we didn't divide it by the power of 2, that gives 2 to the 4. 2 to the 2, sorry. Then we go 2 to the 1, which is 2. And the only value that remained was 1. So there's how 111011 came about.
Oh, so we have to, like, if we skip like a power.
Right, you put a 0 for that power.
Oh, okay.
Right? So if we had 3 and we realized that 4 couldn't go into 3, we're going to put a 0 to signify that we didn't use the power of 2 that equaled 4. Alright? Okay.
Okay, sir.
So I'm going to show you an easier method, because I know some of you guys are probably scratching your head saying, sir, I don't think I can remember all this, So what I'm going to do now, once you finish writing this, I'm going to draw a table that does everything here in less than 2 lines. Alright, so let me time you. 1 more minute to write this off. Time. There we go. 1 more minute. And then we're going to move into the next alternative method. Alright. So this was converting from base 10 to base 2 using method 1. Let me put method 1. My bad. So all of this was method 1. All right. Everybody finished taking it off now? Let me get some feedback.
Yes, sir.
Emma, let me see. Pale, any questions? Nicholas, any questions? After 0?
No, sir.
No, sir.
All right. Emma,
No,
you...
sir.
All right. Remember, if you have any question though, just let me know to say, sir, I am befuddled, I'm puzzled. Query, and I'll answer you. Okay, let's go to method 2 now, which is gonna be very easy. I think everybody will choose method 2 instead. So to help to explain this, I'm gonna use a diagram. Method 2. My bad. There we go. Method 2. So this method involves using a table. All right, let's go to that table. It's on page 42 in the book 2. Page 42 in the book 2. But just in case you don't have the book, I took a picture of it. And we're going to quickly go on it right now. Here we go. Can everybody see the picture? Well, I can't see it, so you can't see it. 1 second. There we go. There we go. Can everybody see this picture?
Sir, I can see.
Yes, sir.
All right, good. So let's zoom in a little bit. Okay, that's probably too much zoom. All right. I know you guys probably saying too much zoom too because you're tired of online class. All right, let's look at this number. Here's the 59 that we were looking at, and here's a table that really simplifies everything that we've been doing. All right. So here's the first step. Write this for me. The first step is to place the value that you want to convert to base 2 on the right. So that's how we put 59 on the right.
Repeat, sir.
So let me write it down just in case. And I'm recording as well. But let me write it down. You're going to say place the value that is to be converted to base 2 on the right. For example, let me draw it right here. If I want to convert 59, I put 5. Then I put the 9. Then I draw a little table and a slash. And then I put 2. Right, that's the first step. Everybody got that down? So let me number the steps.
Yes, sir.
So step 2 now. You're going to now draw a remainder column. So draw a remainder column. Draw a remainder column to the right of the chosen value. Here's an example now. I really should have copied this drawing or placed this drawing down here. There we go. So you're going to put now another column right here. You're going to put R, that means remainder. Extend this line. And every time you find that there's a remainder or not, you're going to put a 1 or a 0. Okay? Alright? So here we go. This book has its remainder column a little bit different, but it's the same thing. Same thing. Because look at it. We have our R beside the 59. They could have had their R beside the 59 as well. Alright? And it would still represent that we had a 1, 1, 0, 1, 1, 1. Alright. Let's do it together now. Alright, here we go. That was step 2. Step 3. Do repeated division by the given base into the number, and in this case the number is 59. So what do we mean by the repeated division? Let me show you. Let's move this drawing across down. Repeated division is to say how many times can 2 go into 59. Let me choose the red marker. We know that 2 into 59 is going to give us 27, right? And we know that, does it give us a remainder? Just by looking at the number, what does 59 end with?
9s.
Right. And we know 9s are not divisible by 2. That's a rule in even numbers and odd numbers. So we know it's going to give a remainder of 1. And you can prove it. You can do a long division right here. You can say 2 into 59. 2 into 5 goes 2 times. 2 into 2 goes 4. Remainder 1. So 2 into 19. Wait 1 second. Extend this down. Alright, so 2 into 2 goes 4. Remainder 1. Alright. 2 into 19.
9, sir. You said 19, sir? Yeah, 9, sir.
Right, this is 9. Sorry, my bad. 29. 29. Right, so 2 into 19 goes 9 times, and the remainder would be 1. See that? Because
Yes,
9 times 2 is 18.
Sir, so it's kind of like finding the LCM?
Right. It's kind of like finding the LCM, or just trying to find out if this answer would be a 1 or a 0. Right.
After 29 divided, sir, 2 divided by 15, sir, 2 divided by 59 is 29.5, sir.
Right, it's 29.5, but guess why, Khalil? Because we have a remainder of 1 right here. Alright? Because now if I wanted to check if this is true, I could have went further and made it a decimal by saying, okay, put an imaginary 0 right here and place a decimal point, and then I say 2 into 10. How many times does 2 go into 10, guys?
2 into 10, 5, sir.
5. So that's how we get the 29.5. But we don't want to go that far. We just want to know whether or not it would have a remainder, right? And then put the remainder under the remainder column. All right, let's do the second one. So we're going to say now 2 into 29. All right. All right. So how much time does 2 go into 29? Let's quickly draw it. So let's extend this column.
14.
14 times. So to save time, I won't divide it every single time. But if you want to prove the number, you can definitely do that. But it would go 14 times. It would go 14 times. Let's draw that. But guess what, Pale? That 14 has a remainder of 1, right? But because you can look at the answer on the end, which is 9, and you'll know at every time that would give you a uneven number. So the remainder here would be 1. Let's put it. Here we go. 1. Now, here's the trick. Now that we know we have a value of 14, if I divide it by 2, do you think I'll get a remainder?
No, sir.
Right. So automatically, I can just move along and say, you know what? 2 into 14 goes 7, and the remainder will always be 0. 0. Alright? Now let's continue now. I'm just going to use 1 ink because it takes a bit of time to change. So now 2 into 14, and then we're going to say 2 into 7. How many times does 2 go into 7?
3 times, sir.
3. Alright? And that leaves a remainder of 1. Right? Because 2 times 3 is 6. And we need 1 more to get to 7. So we're going to put a remainder of 1. Alright? And we're going to say now 2 into 3. How many times does 2 go into 3?
One time.
One time. 2 times 1 is 2. Remainder to get to 3 is 1. So 2 plus 1 is 3. So we're going to put another answer of 1 right here. And the final one, you realize that 2 can't go into 1. 2 can't go into 1. So you're just going to put this one right here. You're going to say the answer is, starting from the bottom going up, is 1, 1, 1, 0, 1, 1. So you always read the value from the lowest going up. So that's the next rule. So after you've done the repeated division, read the remainder column. Read the remainder column from bottom to top. Hence 1, 1, 1, 0, 1, 1. Clear, everybody?
Sir, can I
Yes,
see this
sir.
drawing again?
Sure. Let me just zoom out. Let me zoom out. There you go. Alright.
Sir, why would you add an extra one if didn't you already do like 2 into 1 already?
No. The last one we did was 2 into 3, which goes 1 time. The remainder is 1. But now when I say 2 into 1, 2 can't go into 1. So what do you think I should do? Should I say it has no remainder? Or that it does, which is just its value, which is 1? Right.
Add the extra.
Right. So now I want you to understand. You read the value from the lowest going up. Right. So let me put the arrow, which is in green, to always make sure you understand. But if for example you make a mistake and start writing the value from the top going down, the most I'll subtract is a mark. So you're gonna read from the bottom going up. And always remember to put 1, 1, 1, 0, 1, 1 with the base 2 right below it. Alright. So 1, 1, 1, 0, 1, 1 with base 2 right below it. That's going to take us through the end of today's class. But here's your activity that you're going to do and then submit the final homework, which is to take a picture of all the notes that you have from January. It's not going to be due right now. It's going to be due next week, right? Next week, Tuesday. So here's the homework question that should be included into your submission of your notes. Homework. Convert 26, 67, and let's take 2021. It's going to be very hard. So these 3 numbers to base 2.
Repeat that again, sir.
So you're going to convert these 3 numbers, 26, 67, and 2021 to base 2. This will be due next week, Tuesday, because I want you to submit this work along with all the notes from January as your assignment. Okay?
Okay, sir.
All right. Any questions? So what I would suggest you guys do, and I did this in high school, always do your homework at least an hour before lunch. So you don't have to think about it until next week. Alright? So if you have a little free time right now, just do the homework. So the only thing you have to do now is to submit the notes. Right? And remember, all the notes from September really, or a majority of them, is on this virtual notebook. So I have from October, November, December. Remember, we're in class physically, so some of the classes in January, and then February, and then now March we have here. So these are some of the notes, but then now I want to see all of yours by no later than Tuesday. Alright? Clear as mud, everybody? Okay, good. So for the senior 3 students, are you still there?
No, sir.
You answered me though. Right. I wasn't screen sharing? Okay, I didn't even realize. Right. So for the senior 3 students, let's go through your work now. Quickly, we have 2 minutes remaining. Let's go to the work. Any questions about the work so far though?
Sir, it's 1 to 20, then 41 to 50.
Oh, okay. So I'm guessing she wants you to do a test. Oh yeah.
No, I'm asking, like, it's just revision. We're gonna get some type this for the end of term.
Okay. Smart. So how far did you reach?
I'm done, but like I was asking if the questions are 1 to 20, 41 to 50.
All right. So I'll get further clarity because the 41 to 50 is a different section, which is comprehension and analysis, compared to synonyms. All right. So I'll get some further feedback, but I'm guessing you would have the weekend to finish this, and then Monday you'd submit it.
All right, sir. Thanks.
All right. Yeah. So if you want, I can see how best I can help you. So let's go to the first one. The continuous leaking of the water tap. One second. Let me just download the file and open it. It's a little bit small for my liking. 1 second. Let's go to the first question quickly. Alright, can everybody see this? It's loading up. Right. This is a trick, not a trick, but a DIY life hack when you're answering these questions as synonyms. Right? You're gonna put in the context, and I was teaching this to Ariane and Diksha in the last class. The continuous leaking of the water taps throughout the night caused an interruption of the water supply. What is the context of the word continuous here? Let me ask. Right, it's going on and on. It's non-stop. Alright? Like that Drake song. It's non-stop. So the best word would be the one that talks about the fact that it's continuously happening and it's almost like it's bothering you. Alright? So it wouldn't just be frequent. Frequent means it's happening at some interval. Regular means that it's happening throughout, but it doesn't signify that it's a little bit of an annoyance. Right? Intermittent, that's another interval. Happens, then it stops, happens, then it stops. But the best word to show that it is not only happening, but to the point where it's a little bit annoying, it's incessant. Everybody see that? Alright, good. Alright, so that's going to be the end of today's class. Have a great rest of the day. The video is recorded.